So welcome everyone to Scaling Digital Plan Submission, a real-world use case from LTSA. So we're very honored to have some guest speakers here with us today. We've got Taylor from LTSA, and then we've got Matt and Vincent from our partners over at Silvacom CS. We've done a little bit of introduction already, but I will hand it over to Donald now to introduce himself, and then we'll work our way down the panel.
Yeah, morning everybody. I'm Donald, and I've been with Safe Software just over 2 years. I think it's about 2 years, 2 weeks now. And I'm on the technical support specialist side on the FME forum. That's what I kind of focus on. And I'll hand it over to Vincent.
Thanks, Donald. My name is Vincent. I'm a GS specialist with Silvacom in the CS department, and I primarily solve geospatial problems for municipal and provincial clients. And yeah, happy to be here. I'm going to hand over to Matt to introduce himself.
Awesome. Thank you, Vincent. Hello, everyone. Matt Fisher here. I am the Director of Business Development for Silvacom CS, and my kind of core role is just identifying client needs and connecting the dots between them and our services. So very pleased to be here and looking forward to today's session and the questions that come up. I'll pass over to Taylor.
Thank you, Matt. And I'm Taylor McInnes. I'm the Geodata Manager here at LTSA Landshare. We manage all the spatial portfolio for the Land Title Office, as well as operate Parcel Map BC. And we'll show you a little bit about what that looks like today.
Awesome. If any of our viewers haven't used Livestorm before, this is our webinar platform. So here's a few quick things about that. If you're ever having any audio issues, you can't hear me talking right now, for instance, you can hit the little help button on the bottom left, and there'll be 4 quick steps to help you troubleshoot that. If you feel like it, feel free to give us a emoji react throughout the session. It's always nice. It gives us a little boost as we are presenting down there. I see some little celebration things popping up, so thank you. Appreciate that. If you have any questions, feel free to drop them into the question tab on the bottom right there. We will have a live Q&A at the end of this, and we're excited to pick Taylor, Vincent, Matt, and Donald's brains about this topic. Quick agenda for you here today. We'll start with an introduction that Donald will take us through kind of the basics of FME and how we're applying it in this case, and then we'll move directly into LTSA's specific use case, as well as do some demos about their FME powered solution. And then we'll go through a quick conclusion about some key takeaways and things for other people dealing with similar problem solving with FME. And then we've got some free resources, and we'll move into our live Q&A. So with that, I'm going to hand it over to Donald for our introduction. Presenters, if you're presenting, feel free to keep your webcam on. Otherwise, we'll hide away until we see you at the Q&A.
Yeah, thanks, David. So today we're going to explore how LTSA scaled digital plan submission through automation, turning complexity into consistency. So before I hand it off, I'll do a quick intro to today's topic, as well as an overview of FME for anyone unfamiliar. So let's start with a simple reality. Manual plan validation doesn't scale, automation does. Across land administration, digital plan submission has grown rapidly. There's more submissions, more complexity, more variation in data, and higher expectations for turnaround times. Traditionally, validation has relied heavily on manual review, checking geometries, confirming attributes, validating naming conventions, ensuring compliance with submission rules. Now, all these work until volume increases, until timelines tighten, until consistency becomes critical. At a certain point, adding more reviewers doesn't solve the problem. It just increases cost and complexity. That's where automation changes the equation. FME allows organizations to take complex validation rules, geometry checks, attribute requirements, business logic, and then turn them into repeatable, consistent, and scalable processes. Instead of relying on individual expertise applied one submission at a time, those rules become embedded into an automated workflow. Every submission is evaluated the same way, instantly, transparently, and at scale. So today, we're going to look at how LTSA applied this approach in the real world, and hopefully it will help you get started in making your own digital plan submission tools. So this is just a slide about the FME Enterprise Integration Platform. It's just a big overview. So on the left, we have FME Form. This is the authoring environment. It's where you actually build your data integration workflows. If you ever use ETL tools or model builders, this is the place where you connect to your data, apply transformations, and design how everything flows. Once those workflows are built, that's where FME Flow comes in. FME Flow brings those workflows to life. It handles automation, scheduling, triggers, notifications, APIs, all the operational side of running FME in production. And one important thing to call out here is that we offer flexible deployment options. FME Flow can be deployed on premises or in your private cloud. Or if you don't want to manage infrastructure, we also offer FME Flow hosted, which is a fully managed deployment running in AWS. Then on the right, we have FME Realize. This is about experiencing your data in real world context. Things like augmented reality, 3D, and visualizing assets in the field in real time. So together, Form is where you build, Flow is where you automate, and Realize is where you experience the results, all as part of one integrated platform. We originally started out very focused on GIS and geospatial data, and of course, it's still a big part of who we are. But over the years, as customers' needs evolved, FME evolved with them. From geospatial data through to location intelligence and IT, our goal is to enable you to use your data where, when, and how it's needed, regardless of its source. Today, FME supports 500 plus data types spanning GIS, CAD, databases, cloud, and we go into emerging areas like 3D, point clouds, and AI. So the goal is simple, to help you use your data where, when, and how it's needed, regardless of its source or format. Now, before we move on, we're just going to do a quick chat storm. So I'm just going to throw it back over to David to introduce it.
Thanks, Donald. So quickly before we get into our main topic here, we're going to do a little audience interaction. So if you haven't done a chat storm before, it's pretty simple. I'm going to throw a question up on the screen, and then we're all going to type our answers, but hold off on hitting send, and then I'm going to count us down, and then we're all going to send the answers at the same time. So your question for today is, where do you experience the biggest bottlenecks in your current data or submission workflow? So feel free to type an answer out, but hold off on hitting send there. Give you a second for everyone to think of that. I see we got some people typing. I'd love to hear from Donald as well. What's your answer to this question?
I was going to try some ideas if people were struggling, but one for me would definitely be a schema drift. So just if you're adding or renaming attributes, it's something that always gets me, and it's something that I always have to be aware of. But that would be a main one for me. And then also just like the manual data prep as well. So cleaning the data before submission, that can be a big thing as well.
All right, so we'll get everyone to send in 5, 4, 3, 2, 1, and send. Oh, a bunch of lovely answers coming in there.
Data format, yeah, that's definitely one that I still trip over all the time with.
Perfect. Well, we'll make sure to take a look at a bunch of those there, and our presenters are having to read over it, and Donald's commented on a few. So I will hand it over to, I believe it's Matt is taking these next few slides. I'll hand it over to Matt to go through the LTSA use case.
Thank you so much. Hello again, everyone. I thought that before we get into the meat of things today, we'd first take a glimpse here at what digital plan submission tools are. So at the high level, digital plan submission tools, or DPS as we often call them, are software platforms or systems that are used to electronically submit, review, or approve digital plans and documents. So our discussion here today, of course, is going to be specific to survey plan submissions, but really this technology can work for any types of plans, any types of data. It's a universal problem. We recognize that data validation is a universal problem facing many industries. So here you can see in the schematic, it's a very high level here, but the first step starts with the plan submission over on the left, submit plan. DPS plans can be submitted online using a portal or an existing registry system or even a land information system that has an integrated DPS component. So there's definitely some flexibility there. The next step is just performing an automated plan validation that uses a specification to check the plan submission for errors. And typically our organization works with clients to help identify what is in those checks, what needs to be validated. And, we work with clients that have sometimes like 2 or more, resources are working full time on this work. So it's difficult to keep pace. So that check definitely helps. Now, assuming the plan submission has passed the validation, it can then be packaged for delivery to the land admin organization. And the package can be configured so that the land admin organization receives the data and the information exactly how they need it, right? So you think about where the forever home for the data is going to be. It can actually be packaged and configured to make an easy integration there. From there, with the integrations with the land record system or a parcel fabric, there's even ways to automate the data integration into the parcels. And I believe Taylor will be talking a little bit about that later on in our session today. The last step really just involves configuration of the plan and data and associated land records for distribution to stakeholders. They can be both internal and external stakeholders within an organization. And this is just about ensuring that their needs are met. Now, a little bit about DPS here. So Silvacom CS, my organization, has been developing this technology for actually over 15 years for solutions great and small in various capacities here. So lots of these systems under our belt, we can see there's a few screenshots of some of our key systems. And going back, you'll hear the story today. LTSA was interested in leveraging this technology to meet their business objectives for survey plan validation processes. And you'll see more on that soon. So just one last slide here about Silvacom CS. We're a safe software system integrator. We're also an Esri Gold partner. We work both with spatial and non-spatial FME integrations, of course. We're specialists in FME powered data processing and automation. Of course, that's a key word there. We have expertise in optimizing the tedious, repeatable processes, right? This really helps with capacity, getting ahead of the backlog at times. And we lead the development of end-to-end digital plan submission and data preparation solutions. So this technology is alive. It's growing and changing, evolving over time. So, and you'll hear more a bit about that from Taylor later on in the session too, about what's next for LTSA with regards to DPS. That's it for me. I'll pass it over to Taylor. Thank you.
Thank you, Matt. When Matt was referring to the land administration teams in his previous graphic and highlighting how digital plan submission works, that is us at the Land Title Survey Authority. So that's what LTSA stands for. We are the regulatory body for the province of BC for land titles, survey systems, your property boundaries are what's displayed in Parcel Map BC. We are the stewards of the cadastre. So we have branded that as Parcel Map BC as the authoritative cadastre for the province. And we're really committed to efficiency, quality data, integrity, and we've leaned heavily on the digital data set submission as a core foundation of what we build for a cadastre in the province. To bring Parcel Map BC online, we started this about 10 years ago. Since we've been active, we work closely with Silvacom, who is one of our build partners and has continued to be our development team for the Land Title Office, where we previously had a whole bunch of individual local governments working on independent cadastres as they collected plan information. They'd COGO that into their own GIS system. And we had a number of aggregators in the province that try to bring all of the individual pockets of cadastral information together into a usable provincial network. When we went out to build Parcel Map BC, the endeavor was that we should have a provincial-wide regulated parcel fabric so that the province could have a quality cadastre that was authoritative and from quality source data. The ability, being the Land Title Survey Authority, is that we had the opportunity to mandate a digital data set submission with our surveying community and enforce both a survey plan submission to the registrar as well as a DWG as that digital data set submission to the Parcel Map BC team as a branch of the LTSA so that we could build out this cadastre so that we weren't COGOing and entering in by keystroke all plan information across the province. It was a decision that created the foundation of what Parcel Map BC is today and allowed us to build this stuff out, because having to actually COGO in all of the information per plan, as Donald was referring to earlier, can throw a lot of manpower at that problem, but it's not very scalable. There's limits to that. It's very challenging, very time consuming. Switching to this digital data set format really allowed us to scale up and put the basis behind what Parcel Map BC is today. So that's kind of the foundation. That's who the LTSA is, what Parcel Map BC is intending to deliver. Now I want to take us through the evolution of survey plans in this province. I saw in the chat we had a lot of people from the UK and frankly places far older than British Columbia is. But our journey, the older plans that we have are a couple hundred years old. They're still in old bound volumes and paper plans that we call absolute fee books that are sitting in our vault today. And those are the early versions of some of the survey plan and survey evidence that we've collected in British Columbia. Those are all still valid and accurate plans. We slowly shifted through the Mylar phase. We have our born digital plans that we see today in a more of a PDF format. And this has been a slow and steady shift towards a digital representation of what the survey evidence in the ground is. Today, as I mentioned earlier, we have our PDF plan that gets submitted to the Land Title Office for registration, accompanied by the digital dataset submission. That's filed as a DWG that needs to be in a very precise format that we have a schema control over, and a series of checks and balances are run against that plan submission to validate it for accuracy, topological consistency, validation on what the plan number is supposed to be, and all the metadata that kind of goes into that. I'll take everyone through a bit of a demo of what our surveyor submission platform looks like so we can see the front end, and then we'll jump behind the curtain to see what's happening under the hood with the FME and safe software tools. So the LTSA strategic vision with this digital data set transition is really to have automation be the driving force. We want to be able to integrate plans into our registry and then represent them in a graphical format in Parcel Map BC in an elegant way without having this heavy manual integration step of co-going in all of the line work. The challenges that we were trying to solve are the talking points that I've referred to already, where we otherwise would have a gigantic pile of work that feels insurmountable to manage the entire province in a structured format. We are a team of 8 to 9 GIS analysts that are operating Parcel Map BC. There is no chance we would be able to integrate the plan volume that we see in the province with such a small team without the digital data set submission as the backbone of our workflow. The file format delivery is a combination of PDF and AutoCAD. It runs through our safe software programs and the FMWs to spit out an Esri native file format for Parcel Fabric integration. I believe we'll be presenting at the Esri user conference this year. In case people are interested in what we do for a Parcel Fabric standpoint, there'll be other sessions that can tackle that for you. We wanted to move forward with strict standardization, and that schema drift that Donal was referring to earlier is something that we're very hands-on with to keep locked down and specific. This plan submission has provided very quality data consistency because now we are taking the raw CAD file that the surveyors have submitted. So that's really their internal copy, a very authoritative version delivered to us for integration. So we've got extremely high quality data coming in as an input. It's allowed us to run these things through far quicker. So we have reached a sub 2-day turnaround time from the point where the surveyor would submit their survey plan to us at the Land Title Registry. It's registered in our registrar as well as entered into the map. Right now we're hovering around takes about a day and a half from submission to delivery out the door. That's the high level. That's kind of who we are, what we do, and part of that plan journey. And this is the portion where we want to get into the actual FME powered solution behind the scenes. So when we first built this, we had an independent standalone app where surveyors could log in through a web portal, authenticate who they are. They are a commissioned land surveyor in the province of British Columbia. They have their integration spec that they can validate against to confirm that the TWG file for their digital dataset submission meets all the specifications that are required. We'll make sure that things like the plan number is accurate. We had built an ability to log in, view it on the map, make sure it's actually where they think it's supposed to be, and then submit that package for delivery through a standalone application. But back in 2018, we had kind of multiple portals that these surveyors were responsible for submitting within. And in 2025, kind of early last year, we set up a modern solution for this. And that's what I'm going to demo shortly. This is still using the same core backbone of FME solutions that we built in 2018, performing all these checks and balances that the survey plan is accurate in what we intended it to be. I believe Vincent's going to cover some of our topological checks, which is a pretty cool FMW validating that there's no errors in that dataset submission. It can be really useful for surveyors to catch blunders and mistakes ahead of the submission, so they don't need to file a statutory declaration stating a correction, but they can catch it ahead of time. And we're validating that it's entered in accurately. This has been a kind of a new UI that we built out, and it's now the single portal so that surveyors can both submit their plan to the Land Title Office with the accompanying digital data set submission, all within a single portal. So we're going to visualize that surveyor dashboard, multi-step process. We're going to show what the front end looks like, and then speak to some of the actual validation checks. And then Vincent's going to open up behind the curtain and show us what that FMW is doing. So without further ado, can I ask for the video to be fired up, please? Okay, so this is going to be lightning fast because the intention is to really look behind the scenes. So this is our surveyor portal. What we're seeing on screen is our roboticized test case to validate that everything works. So it's going to come through lightning fast. This is where the surveyor will log in, enter in their plan information to the tool we've called Survey Hub. All the plan information, metadata, and the assembly of that plan will take place here. We'll enter in things like the PDF. And what we're seeing on screen here is the data set validation. And these are all individual FMWs that are validating the content of that plan. So we've checked the combined scale factor, for example, the topology, the structure check. Here's where we're logging into the map to validate that this thing actually is where we think it is. All of these individual checks, while they appear in an elegant framework in the front end as just a validation check, in practice, there's a lot going on behind the scenes on each individual FMW, validating that all of these things are accurate and intended. So this is one chunk of the way that we're using FME today. We're also using post that submission after it's gone through these validation checks to stage up each individual data set into a Esri native file format ready for Parcel Fabric integration. So all of the behind the scenes submission, delivery, and packaging of work is handled by FME. And we're running that through a series of different FMWs to really connect all of the dots to be able to perform digital data set submission and plan integration. What we're seeing on screen here now is the surveyor creating their plan, validating it for submission, signing it as their authoritative stamp, saying, I, as a commissioned land surveyor, have commissioned this, signing it in and depositing that plan number. If we carry forward, it will show the actual full submission from end to end. I think we've touched on the important FME components, and I think we're probably ready to hand over to Vincent at this stage and take a peek at what the FMW is doing for topology.
Thanks, Taylor. That was great. Let's see. I think I have another slide here. So just before we get into the FMW yourself, I kind of want to just touch on maybe what topology is for the people that I feel like everyone here knows what it is, but just in case we've got some like other people that maybe aren't GIS experts, what topology is basically referring to the spatial relationships between features in GIS. So that gives us a framework to describe how features are related to each other. So we could say maybe like two features intersect each other, or they share a boundary, or maybe one feature is fully contained within inside another feature. Like, these words sound a little silly unless you've seen them before, but it's pretty common ways that we think about how features are related to each other. With that in mind, for LTSA, the purpose of the parcel topology check is to ensure a couple of things. We want to make sure that the submitted CAD file has valid closed polygons and that the line work is clean of dangles, overshoots, and duplicates. There's a few other geometry issues that can cause problem for fabric integration that also get flagged, like self-intersections and unsplit intersecting lines. Now that that's all out of the way, let's take a look at how we've chosen to tackle those problems. If I could get the video going. So this is the CAD topology workspace at a whole. I'm just going to zoom in first to where we deal with the parameters. And yeah, so obviously LTSA as the authority takes in a lot of different kind of survey plans, but what needs to be validated varies between different plan types. So to accommodate this, the workspace takes a simple text input parameter, and we just have it. Yeah, it's text, comma separated, and we have the app pass in the list of layers that it's interested in being validated. So that makes things easy. We're going to first store all that information in each feature that comes in with an attribute creator and directly assign the parameter value into an attribute. We're going to do a little bit of formatting to make sure everything's consistent. Just uppercase everything that's coming in. And then from that attribute, we're actually going to split it into a list to make it easier to identify stuff. So we're just going to take that comma separator and break this all out. And then finally, for each feature that's coming in, we're going to check the AutoCAD layer that the feature is on and check essentially if it's one of the layers that we're interested in validating. So that is essentially what we do there. And a little bit of cleanup. We don't need that list anymore, so we're just going to get rid of it with attribute remover. We're only really interested in analyzing lines, but obviously when it comes in from CAD, sometimes the geometry comes as other types. So we're going to convert everything over to simple lines. So we're using a geometry filter just to filter lines, polygons, and arcs. We're using the arc stroker, convert any incoming arcs and interpolate them into line segments, and use a geometry coercer just to make sure everything comes in as a line. And then in the past, we've seen sometimes the AutoCAD generates incredibly small lines that pop up and trigger errors, but realistically, they don't actually cause problems in the parcel fabric because they're smaller than the spatial resolution. So we're filtering those out, and that's like less than 1/100 of a centimeter. So that's pretty much it for initial reading. Let's see, we should be, let me zoom out and let's go to this top portion. The bookmark kind of alludes to it, but we're going to be dealing with cleaning and checks for the parcel and interest lines up here. And yeah, since we're only talking about parcel interest lines, we don't really want other layers. So we're just starting off by using a tester, and we're filtering out the resolved lines, which is often submitted as other parts of plans. What we're going to do first is, before identifying the dangles and overshoots, we're going to attempt some cleaning. I forgot to mention, the workspace is a parameter to define tolerance that we allow small gaps and overshoots. We'll see how that comes into play shortly. So we're going to take all the data that we convert into lines and intersect them together with the intersector to split the lines where they meet. Yeah, the intersector will do that for us. And yeah, so following along from that, first, I want to calculate the length of everything that's being processed, and we just use a tester, filter everything that's not in the tolerance. And then we want to use a snapper, and with that tolerance set, like we're gonna close small gaps to the endpoints. And anyone that's ever had to draft or work with particularly complicated survey plans knows there's a lot of time and effort that goes into it, and sometimes small mistakes happen. So catching large errors saves our technicians time diagnosing and dealing with issues, but automatically handling these small errors saves the customer a lot of hassle and otherwise keeps the system moving that would have been delayed if we didn't handle those. So we've snapped everything within tolerance to our endpoints. If we still have issues now, these are going to be like dangles, and we're going to find them. And we're looking for the start and end point, extracting those coordinates with the coordinate extractors like index 0, index -1 to get first and last. Convert those into vertices with the vertex creator, and then we're just overlaying them. And the idea is that if the plan was clean and everything closed, every start point should overlap an endpoint and vice versa. So if we've got a dangle or a gap, we're going to have a line with an endpoint that's like floating off in space and has no overlaps. So that's what we're going to look for. And if we find any vertices like that, we're going to pass those along. Those are errors, and that will come out in our XML output, which I think I can just, we're not going to look at it just yet, but just a little peek, zoom over there, all gets passed down the line. Okay, so the next check is unsplit intersecting lines. It's something we could handle automatically very easily with FME, but something we structurally don't want to see coming in from surveyors, so it's worth sending it back to them. Essentially, what we're trying to do is identify places that two lines intersect, but they don't correspond to the endpoint of the line. And so we're going to do that by breaking every line down into component vertices with the chopper. Like you can see, we're only outputting one vertex. And then with the intersector, we want the significant nodes. And whenever time two lines cross, it will generate a node and have a node number. And now we're overlapping them again. We're trying to find a place where, yeah, the lines cross, but that intersection, essentially, if there's a node number there, then we know that means that if there's no overlaps, but there's a node number, that means, yeah, like this was a thing that did not correspond to an endpoint. So that's essentially what I'm going to test for here. So yeah, we're looking for no overlaps and not node number missing. Sounds a little weird when you read out in English, but yeah, we're looking for the presence of a node number essentially. So that indicates then that we found the problem that we're interested in. Moving on from there, we're just doing a little bit of formatting. We're going to get those coordinates of that error point. We're only interested in 3 decimal places with the string formatter, putting it all into one attribute, and then we're duplicating or filtering for duplicates rather, because we don't really need to double report this issue. Just knowing that it exists is enough, and send it to XML. For duplicates, still kind of on this theme of like point-based detection, we're essentially comparing the center points of each line. And to do that, first we got to handle those arcs we previously stroked. We're just checking if the original entity was AutoCAD arc, and we're chopping those stroked lines down into individual line segments. And then from there, we're going to use center point replacer to calculate the center points. I'm ahead of my own recording. There we go. Click it. Yep, yeah. In newer versions of FME, there's a few different modes. We're using the default center point of the bounding box. And then essentially what the deal here is that if we had lines on multiple layers that were duplicated, we would expect then that the center points would be identical. So we're just getting the coordinates again, and this time with the duplicate filter. If we have multiple points that have the same coordinates, then we're going to identify where they're duplicated and pass those along. So you can see we're using a lot of the same transformers, but different functions of them. So that's pretty neat, being able to like either use the nodes or use the duplicates. There's a lot of power in these transformers that, like, yeah, just need to play with them, get used to them. Finally, we've got a self-intersecting geometry check. This is very easy. We're using Safe's out-of-the-box geometry validator. It has a lot of different issues you can detect. We're just using the self-intersections in 2D. Any issues that get found get output as a list. So for us to get those coordinates, we need to use the list exploder to essentially access those easily, break them all into individual features. And then we're just going to rename the coordinates back into the same format we were using before, do some cleanup again, because we don't need all that stuff passed along. And we're reusing that same little bit of formatting, concatenating, and filtering out the duplicates. And yeah, like we're calling all these overlaps. They're not all necessarily overlaps, but they don't also get told to the customer. They just see the location that is in error. For the purpose of writing XML, we obviously need features to go to the end to write a file. So we're using the no features tester. And that will ensure that we'll always get something as long as we output from the output as well. So if nothing is found, we're going to say the check passed. If something was found, then we're going to say the check failed. And so we just pass a true false Boolean. And then from that point, we're just going to send everything through duplicate filters because we don't need double reporting as mentioned before. In the XML templater, nothing too crazy happens here, but we really just need to pass some key pieces of information, the check pass fail, which happens at the top with the found attribute. And then we start constructing the tree structure of the XML by calling these templates beneath. So root calls layer calls sub, and then sub contains our coordinates of where the error points are. Yep, from there, we pass through the XML formatter and XML validator. We don't really do anything special there. Those are pretty default, but that all goes into an XML file that the front end uses to display where the errors are. So maybe we should see what happens if I push a file through that I know has an error. Let's go run. Yeah, I've pre-prepared this. I think I need to increase the tolerance or decrease the tolerance rather so that this will fail because I know how long the overshoot that I've got in here is. It's about 3 millimeters. So tightening up that tolerance so that it won't pass. But so I know it's going to be in this top portion. We can kind of see from the flow results that we've got something that's being caught in this tester that's being sent to the output. Let's try to visualize this. It'd be easier if we could see the lines. Let me add the lines from the intersector. Okay, so now it's a little bit easier. We've got the point that was identified, that endpoint, and yeah, we can see this dangle. Since I calculated the lengths, we can see it is 3 millimeters. So really tiny. Normally this wouldn't be an issue, but we tightened the tolerance. And then as for the XML output, just to look at that structure, I should be able to do it from the validator before it goes out. Yeah, XML out. So yeah, we can kind of see that at the top, the features found them. That's our check. We're saying it's false. And then we pass those coordinates for the failure. And then the front end will use those coordinates. So now we're just going to go back to our regular tolerance of 5 millimeters. Run through again. And this time we won't see a feature flow to the end. But yeah, now you can see because this tester is catching for things in the tolerance, like that gets filtered out at this stage. Like we use this tolerance across the entire app in other workspaces as well, and other things to make sure it's consistent. So it's not hard coded in the app, but something that gets passed in at every step. And then because we use that no filter, we can see things go to the no input. So we still get an XML output that we need. And yeah, but we just say passes check is true. And yeah, I'd say that's basically it. I don't know if I have anything else in this demo, so I think I should hand this back over to Taylor to talk about like some of the results of integrating FME checks.
Thank you, Vincent. Yeah, so we talked a little bit about our surveyor submission dashboard, how plans get submitted, and then Vincent showed us under the hood on what's happening on topology. To wrap this up before we get into our question period, did want to tackle how much volume we're actually seeing. We referred to earlier how doing this on a manual basis and co-going in these plans would be unwieldy. What we're seeing on screen is the volume of survey plans submitted and completed by the internal geodata team on a month-by-month basis. So you can see we hit high watermarks of almost 950 plans in a month. And as a team of between 8 and 9, we just couldn't do that if we were manually entering all these things. And we really do need that digital data set platform to be able to work through the volume of content that comes through. So being a provincial-wide cadastre, we can have things from all the way up north. BC is a pretty big province to in the densely populated area down in Vancouver in the south. So having this platform allows us to scale. And that's the real focal point that I want to hammer home here, that we don't hit that glass ceiling because we've got the tools at our disposal to be able to process these things in large volume. The last slide is kind of calling out that same core content. Instead of on a month-by-month basis, we can see we've almost processed 80,000 plans through this system. And this is kind of the one we referred to earlier. We built it back a little over 10 years ago when we went live, and it's lived relatively untouched ever since. So it's been built in a way that was very strategic. We've been able to kind of upgrade it along the way, but this has been a piece of code for us that's been really bulletproof and extremely reliable and has really solidified that foundation of our core operations. So that's the volume. That's kind of the culmination of a survey plan submission. And I done kind of talking about what we've done so far. What's coming next for us at the LTSA is automation is key for us. So we are very keen to continue to leverage FME in new ways to integrate our surveyor data into the parcel fabric. We are in the midst of a tool that we're leveraging within a series of FMWs that automates what we call posting plans. Posting plans in this province are surveys that don't change the on-the-ground location of any of the parcel representation. It just reestablishes with modern evidence where those pins in the ground are. So we've got a modern survey plan with XY coordinates on it. We are endeavoring to automate the workflow of that from end to end so that a technician doesn't need to do any data integration. That's what we're doing today. Vincent's actually very hands-on that project. We're looking to go live with it in the next couple of months. So we'll be able to automate a portion of those plans that are coming through on a month-by-month basis. As well, we're also looking to revise some of our data product delivery. We use FME to package all of our external content that we send out to our end users. So we've got stuff on our BC data catalog. We send stuff to local governments and surveyors. All of that runs through a series of FME scripts that are packaging the content for the end user according to what their needs are. So we're looking to rebuild and modernize some of that with some fancy APIs and different mechanisms. And we'll be leaning heavily on FME to do that for us. So that's what's next for FME. And I believe I'm handing over to Matt for a conclusion and wrap up.
Great. Thank you so much, Taylor. Hello again, everyone. I just want to kind of sum things up. I mean, let's face it, many organizations are currently struggling with data validation, right? You've heard the story of how many hands it takes to do this work. It's a universal problem. It's taking companies time, it takes money, and it really doesn't have to be that way anymore. By leveraging FME technology, all this validation processes can be automated. So that's tremendous news. I'm going to pass over to Vincent now just to give us some insights into, I guess, the history of the work that we've done and some recommendations as well. So take it away, Vincent.
This is essentially going to be some takeaways from us doing some implementation. First point is try to keep the scope and context of the project in mind when designing solutions. I mean, I'm a technical person. I'm sure a lot of you are technical people, and it's easy for us to go down a rabbit hole when we see an interesting problem and solve for things that maybe aren't being presented. Like, we're all just planning ahead is really great because we're maybe potentially future-proofing things. We're also spending time and money in a budget that maybe isn't quite so large and broad, trying to essentially solve for the problems that are being presented instead, especially like if you are working with someone that has the authority to define a standard. Like, we're going to be seeing less like strange, like niche problems. Like, we can design a system that we can build if those issues come in the future, expand upon, but we should, just solve for the problems that are at hand first, and just make sure the system is flexible enough that if new problems arise, that you can integrate it in without like tipping over the whole cart. Second point, I think this is fairly obvious to most of us, but like, as if a coder puts complicated logic in, hopefully they put comments in so that other people down the line can understand what's going on. And consequently, as an FME professional, we should do something similar. We've got the capacity to use bookmarks and annotations, and that'll make it easier for future FME professionals to help maintain these workspaces. Obviously, it can be really frustrating if you take on someone else's work in the future and they haven't left you any hints as to what grand logic or novel solution that they've come up with. Useful hint maybe is almost everyone nowadays uses some kind of ticketing system like Jira, which often has like context of the problem that was trying to be solved, maybe some input parameters and data sets. And it's often useful just to embed those ticket numbers in. And also that because workspaces are XMLs, it's easy for source control to be able to pick those out. So it makes it easier to try to jump straight to the places that have the issues and understand what's going on. So that kind of leads into the third point of keeping a repository of test data and results handy. Like, you can get some of that from those previous Jira tickets, but as Taylor mentioned, like, this system has existed for almost 10 years and still kind of rock solid. Part of that consistency is being able to have a set of use cases, like trying to test edge cases or other novel things that come up once in a while. Once we've solved the problem once, we don't want to see that as we upgrade through versions that the problem recurs. So we need to be able to reproduce those exact cases. So having that on hand makes sure that we don't reintroduce the problem. And then finally, like you saw from that demo just how fast those validations were happening. Speed is king. And the way to have speed is minimize the data that you're passing along. Like, that happens a few different ways. You can see like in the FME workspace, often using attribute removers, cleaning up data that doesn't need to be used downstream. It could be like shoving as much stuff as close to the data source as possible. Like, do queries against the database rather than bring it into like the local memory and then doing querying. Or if you're working with cloud, like often we have stuff in S3 buckets, maybe either CSVs or JSONs that you need to filter something out. Use something like DuckDB instead, so you can query directly at the source rather than bring it to the server and incur all that overhead. So I'd say that is basically it for my tips. I think I'll pass it back to Donald to wrap up.
Yeah, perfect. Thanks, Vincent. So I just want to extend a huge thank you to Taylor, Vincent, and Matt for partnering with us on today's session. So it's always amazing to hear directly from teams applying these solutions in the real world. So that our perspective and collaboration makes sessions like these incredibly valuable, not only to people at SAFE, but to the wider community of FME. So thank you all. It's great to see others using FME in action. So of course, FME isn't just a product, it's a global platform. So with over 25,000 organizations, 200,000 plus users, and customers in 128 countries, it's a community that spans industries and continents. For more than 30 years, we've been helping organizations solve their toughest data challenges. And at the end of the day, this is what FME is about. All data, any AI. Organizations don't want locked in data or locked in AI. They want freedom, and FME gives you that flexibility. No matter the velocity, location, or type of data, FME gives you the flexibility to prepare it and connect it to the AI, to the AI technology of your choice. So finally, I'm just going to hand it back to David, and he's going to go through some really useful resources.
Yeah, thanks, Donald. And thanks again to Taylor, Matt, and Vincent for joining us today. It's always a pleasure to have customers and partners on here showing us their real world use cases. A couple resources for everyone today. These are all free resources. We love our free resources here at SAFE. We got a couple links here, including a customer story from our friends over at Silvacom CS featuring LTSA, as well as some links from our site and knowledge articles about digital plan submission. So you can download those by going to apps, handouts, and downloading our slide deck, or you can download it from the link we'll send out after the event as well. A couple other free resources for you. We have our webinar program, of course, lots of great upcoming webinars and many on-demand webinars that you can find on our site, as well as our knowledge base, our FME Academy, and even an ebook that we've got as well. So if you're looking for any next steps here, feel free to get in contact with us. Send us an email to info@safe.com. We always love to hear from people looking to get started with FME. You can also take our FME Accelerator, which is a 90-minute crash course in all things FME. Once again, totally free as well. And finally, if you haven't joined our community yet, that's another great resource. You can head to community.safe.com. and you can redeem a badge code for watching things like webinars. So the badge code for today's webinar is on the screen. I've just thrown it in the chat as well, so feel free to redeem that. Our community is a great place to interact with SAFers and the general public of FME users and get your questions and answers. So speaking of questions and answers, it's time to head into the Q&A portion now. So if I could prompt our presenters to return back to the stage now. We have got a few questions that rolled in. We've answered some of them, but if it's okay, we've got multiple answers. So I'm just going to read out Randy's first question here, and we'll start with that one. So Randy asks, how do those who create or submit data know what standards, e.g. layer attribute names, topology rules, they are to follow? What happens when they don't and submit unstructured data? Can you work with such unstructured data, and how? So maybe we'll start with Taylor. I feel that you can read out your answer there, or you can expand on it a little bit as well if you like.
Happy to expand on it further. So we do have templates that surveyors are using as that kind of basis so that they're all following a consistent structure. We found that because we're a provincial regulatory body, that these DWG file format structures, surveyors have become to use those as their norm, and they're also submitting other things to local governments and other government agencies in that structure because now it's become their base template across their organization. So we've introduced that. They've been quick to adopt it. We work very closely with the surveying community to create Parcel Map BC and those regulations on the data set submission standards. So we've really partnered with them to make sure we found the right fit so that it's not over-prescribed and they have no flexibility. So it's been a really good two-way street. That's kind of how we're making sure we're getting some of that consistency from a template standard And then when we're working with more unstructured data, we do still run it through effectively the same series of tools, but we don't go through the front end anymore. We want a little more control over that data set, and we'll run it on the back end, effectively hitting the same FMWs, but it's more like a manual copy with a few tweaks here and there so that we can bring in some of these edge cases. So that's typically how we handle it. Hopefully that's enough context. I think Matt had some good tips and tricks. Maybe I'll pass to him before we ask if Randy's got follow-up questions.
Awesome. Great. Yeah. Thank you so much, Heather. Yeah. You know, like there are jurisdictions that have regulations, which really helps, but let's face it, sometimes there are jurisdictions that may not have it. So unstructured data can happen. And there are a few ways we have helped our clients navigate that. Change management is always important, both inside an organization and outside. So if you have surveyors or whoever the data submitters are, you want to be able to entice them and help them identify the value in the process in this change with the FME technology. So a few things to kind of highlight as solutions to get around that. Sample data or templates, as Taylor has mentioned, that really goes a long way for them to be able to kind of download a quick, simple file, see how it measures up with their workflows in-house and make a couple tweaks from there. Also an informational website, just to kind of, or web page to kind of help explain the value proposition to entice data submitters, explain what they're getting out of it. Faster turnaround times is always like a really good one because let's face it, that can impact the bottom line at times for those companies. We also developed like a data mapping interface for one of our clients where essentially allows them on upload as it's like scanning and checking the file. If there's maybe 10 key pieces or components of the data that need to be checked, if 5 of them were a bit suspicious, a bit off, it can say, is this component actually mapped to this component? It's a drop-down list. You map it once, it remembers you based on your user account, and then that way you have smooth sailing from there on in. So there's kind of little tweaks or little ways you can work around it like that. Also, even better, it's the 21st century, everyone. AI, right? Silvacom is actually developing technology, AI technology to deal with unstructured data where it can actually recognize and still make it work. You know, like what types of data it is, what the intention is. Maybe there's a bit of an exchange, you know, like agentic AI to understand or ask some questions, query this data submitter there. We actually have like a tangible functional proof of concept that right now it's going swimmingly well. So who knows, maybe we'll be back here to do another webinar on that and kind of expand and our DPS services and tell a deeper story on that next time. That's all I had for that.
Awesome. Yeah, that's great. Thanks for answering that. We've got a second question from Randy as well. So he's asking, you've mentioned results being put into XML. How are these conveyed to the data submitted so that they can fix problems? Are data corrections made automatically?
I think I can probably answer that. So in Taylor's demo, we saw there was like a map check portion where we kind of validate that the plan fits where it is. But at that map check is also used, the coordinates in that XML are used to generate points so that where errors are located, like they can visualize where the errors are as well. So it'll become a temporary layer that's on that map and they can zoom in. So I don't think we send them a file that has those coordinates, but there's this visual way that they can see, because the chances are they only have like 1 or 2 problems. Like they'll be able to identify where those are and send that back to their drafter to make those corrections. So that's essentially what we do there. There are some things that automatically get corrected, like I mentioned, like small gaps and overshoots with that tolerance parameter. Like sometimes drafters don't have their snapping settings on, like they don't quite have it snapped to endpoints, but it's usually so small they can't see it. So that's essentially the main things that we would do for handling that stuff. I guess also some parts of the workspace, like we use intersectors, and that will naturally split some things apart where things come together. But obviously we mentioned like non-split intersecting lines, we don't want to see that because it's bad for the parcel fabric. So we still flag those errors. But yeah, there are some small things throughout the system that are consistent that like do automatic correction that way. That's about all I have. I'm not sure if Taylor has any additional comments on that.
I think you covered all of it.
That's good. Yeah, I just wasn't sure if the front end, if we do anything else for the surveyors other than the visual map check to show the errors.
That and the checkboxes for each validation, right? So that's the interface. So nothing beyond that.
Yeah, that's right. If there is an error, we didn't see it in the demo, but like there will be a link that if an error is present, like the message itself is a link, it pops up a pop-up and they can get all the coordinates of everything that's there. So they actually do have a way they can copy it out and not just have to like send screenshots or something silly like that to the drafters. Yep, that is true. I forgot about that because I don't work on content.
I could add a little something to that too, Vincent. Like, yeah, that kind of like that little report generation of what the errors, like if you fail to meet criteria, we have configured some of our DBES solutions to provide sort of a text document or what have you. That way the surveyor has something to take away in their pocket, so to speak, go back off into CAD or what have you and make those necessary updates and changes. They can resubmit. And yeah.
Perfect. All right. So Taylor's answered another one's from Steve here. Do you have a complete, accurate parcel map for all of BC? Taylor, if you like, you can kind of read out your answer or expand on it.
Certainly. Yeah. So our cadastre covers all of British Columbia. We make that publicly available. It's free and unfettered access. We've got a number of attribute specs. So depending on who you are, we're allowed to give different tiers of attribution. But from a graphical standpoint and a map representation, we have all surveyed evidence of the province. So if it's Crown owned, privately owned, doesn't matter. If it's been surveyed and filed in either the Crown Land Registry or Land Title Office, it is mapped, and that effectively covers all titled parcels in the province. Yep, we have complete access and coverage. We do have varying degrees of accuracy. So based off of when the latest surveys come in, we've been online for 10 years. If we've received a survey plan through this digital data set platform, then they're really accurate. We bring everything to the modern survey evidence. If we haven't received a survey plan there since we've come online, we've got some tools to assess how accurate we think each individual piece of fabric is, but we're only as accurate as the source data we were able to collect. So some of the very rural areas that hasn't received a survey that may have been drawn on a paper napkin and digitized in 30 years ago isn't going to be that accurate. And until we get some survey evidence to correct that, we're kind of at the mercy of the source data that we were provided. And we've tried to highlight that. I've attached a web map where we've assessed accuracy across the province. And we've tried to communicate that to our stakeholders saying, hey, this is the best that's available, but take it with a grain of salt. This parcel might not have as much real world accuracy as we're wishing it did.
Amazing. Thank you. All right, we've reached the top of the hour now, so that concludes our webinar. I did see Randy had one more question there about Silvacom's use of AI. I know we have also Leanna from Silvacom in the chat there. She's dropped a link, so feel free to take a look at that. And then if you're interested in Silvacom's use of AI, feel free to reach out to them as well. So once again, thank you, Taylor, Matt, and Vincent for joining us today. It was a pleasure to have you on and to have everyone attend. Thanks for answering all those wonderful questions. And yeah, we'll see y'all later.
Thanks, guys.
Thank you.
Thank you very much.